Okay, welcome to the new chapter, Quadrilaterals. And today's lesson is going to be about classifying quadrilaterals. We're going to have a lot of important information in this, and to be able to adequately take notes for this chapter, I want to make sure that first you have completed the foldable that you're going to keep these notes in. And this foldable is going to help you keep track of the different properties and theorems associated with each of the quadrilaterals that we're going to be discussing. So let's first talk about our objectives, and you can see that from the length and complexity of these objectives, we've got a lot to learn about in this first lesson. First of all, we want you to be able to learn to define and classify special types of quadrilaterals in the following ways. We want you to be able to see what they are using notated drawings. So these are drawings with, congruency marks, parallel marks, things like that. And also from sets of coordinates, which is going to involve a lot of math. Okay, you should also learn to express the properties of special types of quadrilaterals in Venn diagrams. Okay, that's because many of these types of quadrilaterals actually are special types of, they're subsets of each other. So Venn diagrams tend to work well for this. And finally, you want to learn to express the basic properties of various quadrilaterals, learn to use the basic properties of various quadrilaterals to solve for unknown values algebraically. So we do have some algebra involved in this as well. Okay, first of all, we want to talk about the general properties of quadrilaterals. Under this first thing, we're going to have general information here, and we will talk about that more in class. But a good thing to put under the general properties of quadrilaterals would be this diagram here. And this diagram basically shows us where we're headed. First of all, we can have a general quadrilateral which has just any random four-sided figure, okay? And then we need to look at this random four-sided figure and see, do we have parallel sides? If we have one pair of sides that's parallel, it could be a trapezoid, or even an isosceles trapezoid, okay? If we have no sides parallel, but we do have one pair of congruent sides and one pair of congruent angles, then it would be a kite. If we have two sides parallel, then what we have is a parallelogram. And there's different types of parallelograms. If all our sides of a parallelogram are congruent, then it's a rhombus. If all our angles are 90 degrees, then it's a rectangle. And if we have all sides congruent and all angles congruent, then we have a square. Okay, so these are the various types of quadrilaterals we're going to be talking about in this next chapter. So let's define what our special quadrilaterals are. First of all, we have a parallelogram. This is a quadrilateral with two pairs of opposite sides that are parallel. A rhombus is a parallelogram, so this is a subset of the parallelogram with four congruent sides. A rectangle is a parallelogram with four right angles. And a square is a parallelogram with four congruent sides and four right angles. So a square is both a rectangle and a rhombus, as well as a parallelogram. Rectangles may be squares, but they may not. Rhombuses may be squares, but they may not. Okay? A kite is a quadrilateral with two pairs of adjacent sides congruent and no opposite sides congruent. Now, this figure also has other properties, but we'll talk about those in a later lesson. And a trapezoid is a quadrilateral with exactly one pair of parallel sides. A special type of a trapezoid is called an isosceles trapezoid, and this is a trapezoid whose non-parallel sides are congruent, which by the definition of isosceles means you've got base angles congruent and a whole bunch of other properties that we'll talk about later as well. So, classifying by coordinate methods. Okay, if all you're given is a set of four coordinates, okay, that means you can graph these coordinates and look at them and see different things, but you can also determine the slope between the sets of points, and that will help determine the shape of the object. So what you're looking for is, do you have slopes that are the same, or slopes that are different. If you have no slopes that are the same, then it's not going to be any special type of quadrilateral. It'll just be a random quadrilateral. If you have one set of, or it might be a kite, okay? If you have one set of parallel slopes, then it could be a trapezoid. If you have two sets of parallel slopes, it's going to be some type of parallelogram. And then we're going to use our distance formula to find the distance between sets of points to check for congruent sides. And that's going to help us further determine what type of quadrilateral it is. So let's look at some of these points. Okay, here. So I'm going to give you this point here. Ooh, that's a big point. This point here. This point here. And this point here. So this is A, B, C, D. Okay? So A is -1, +1. B is 1, 5. C is 5, 5. And D is 3, 1. Okay? So we need to check the shape of these points by determining the slope. So the slope between A and B is going to be 5 minus 1 over 1 minus -1. So that is going to be 4 over 2, which is 2, right? And then the slope of the line BC is going to be 0. Slope of the line CD is going to be 5 minus 1 over 5 minus 3, which is 4 over 2, which is 2. And slope of AD is also 0. So what we see here is we have one set of sides that's parallel and another set of sides that's parallel. So we have a parallelogram. Now we can use our distance formula to check to see what the distance is between these points. Now we can see that the length of BC is just 4, which is also the length of AD. Okay? So we know we have one set of sides congruent. Now we need to check the distance between A and B. And so that's going to equal the square root of, let's see, 5 minus 1 squared plus 1 minus -1 squared. So that's the square root of 4 squared plus 2 squared, which is the square root of 16 plus 4, which is the square root of 20. Now that is not equal to 4. 20. But it is going to be equal to CD, okay? Because the numbers are going to end up subtracting out the same, okay? So what we have here is not a rhombus, okay, because the four sides are not congruent. Even though it looks like it could be, it's just a parallelogram, okay? So that's how we would work with this and determine what type of shape we're looking at with coordinates. Here's another way we can do this. Solve for x. We're given that this is a rhombus, and we're given that the perimeter is 64 inches. Now with a rhombus, we know that all four of my sides are congruent, right? So my perimeter is going to add up to the length of all four of those sides, which is 4 times 4x plus 2, which should equal 64. Now, doing a little math, you can either distribute this or not. It's up to you. 64 divided by 4. I'm not going to because it's a little bit easier if I don't. So 4x plus 2 is equal to 16. So 4x is equal to 14, and x is equal to 14 fourths, which is 3.5. Okay? So now we can find our side length. So 4 times 3.5 plus 2 will be, the side length is 16, however many units that is. Okay? So what we've learned, quadrilaterals can be classified based on the number of parallel sides as well as the number of congruent sides and the types of congruent angles. We can classify them using either drawings with given notations, descriptions, or sets of points. And we can draw these classifications using flow diagrams or Venn diagrams. And there's a particular book assignment that I would like you to make sure to complete that discusses the Venn diagrams, and that is number 36 on page 292. On page 292. That is very important that you work through that to make sure you understand how to use Venn diagrams to describe various sets of quadrilaterals. Okay, so make sure that these notes are taken well and that you can understand what we're doing here. It's a very important set of concepts, and all these lessons will build off of this lesson. So take some time to really do the book work, do the con work, make sure you understand the properties that are the basic properties of all these different types of quadrilaterals.